Okay, so this video focusing on more chemically relevant conversion factor type problems. And so there's just a little bit of things that I want to introduce at the beginning before we get into some more practical examples, more chemically relevant examples, like you'll see in your homework and in your Chem 101 work, all right? And actually, we're going to start with density, which is a concept that you're probably familiar with, all right? From high school, from other science courses, you know that density is defined as mass per unit volume. Usually in high school, you write things like D equals M over V, where M is mass and V is volume. And what I want to point out, sort of piggybacking on everything we talked about in the last video, is density involves a fraction. And whenever we see a fraction, what we see is a conversion factor. And we want to develop just this ability to see, okay, yeah, every time I see something per something, every time I see a fraction, I know I can take the information in the denominator and convert it to information in the numerator. Density allows volume information to become mass information. We also know we can flip conversion factors, okay? 1 over density would be able to take mass information and get volume information. If you understood everything that we have to do with conversion factors, whenever we see a fraction, you enact problems associated with that type of physical property in the same way, right? This semester, what we use for density is we use the symbol rho. Now I'm going to put an X down here because this is going to be a placeholder for some substance, like the density of water or the density of lead, like down here, okay? It is still mass over volume, so it is still M over V, but what we'll see is that we'll be giving a number, and oftentimes our density is in grams per milliliter. Now, most people kind of stop writing there with the grams per milliliter, but for organizational purposes, it's important for me, and thus it's going to be important for you, to include a value there that identifies the density that we're talking about. What I mean by that is, say this is the density of water. We want to make sure in our math and in our work, we identify it as the grams of water per milliliter of water. Density of water belongs to water alone. And so we use that identifier on the top and the bottom, okay? Come down here to this example real quick. Here we have the density of lead. When you look up the density of lead in a textbook, online, what you'll see is that it's 11.34 grams per milliliter. What we have to do for organizational purposes, we have to go a step beyond that and say that we understand that this is a property of lead. Density of lead belongs to lead. So that's how many grams of lead there are in a milliliter of lead. And we include that in our work and we include that in our calculations because when we get to more complicated scenarios where we have multiple objects sort of being analyzed simultaneously, that identification is going to become critical, right? Let's go back up here, right? So if this is the density of X, it would be grams of X per milliliter of X. You might see it also written as grams per centimeter cubed. Now, if you look at this section right here, we actually build another important conversion factor, right? Grams of X per milliliter X is the same as grams of X per centimeter cubed of X. So what that tells you is 1 milliliter is defined as 1 centimeter cubed. So that's just another conversion factor to kind of have in our back pocket to be able to use when we're dealing with going between different types of measurements, okay? So just a quick little recap of everything about density. Density is definitely mass over volume. We know how to calculate it, take a mass, divide by volume, but in terms of how it fits into work that we've done before in terms of conversion factors, it's a fraction, okay? So we can take something like the density of lead, 11.34 grams per milliliter, and convert from milliliter information to grams information. And we'll see that with the next example. Before we get there, there's another set of conversion factors that, again, you've probably saw before, but are also incredibly important for us. And you'll find these on slide 3 of PowerPoint 1. And we're going to label these as prefixes, okay? You'll see a lot of prefixes there, but pay attention to the ones that are bold. Those are the ones that we use most often. These are definitions, all right? So what you'll see is that there are prefixes for certain units. For example, there's centimeters and there's meters. So the centi is a prefix. Now, on that slideshow, which you're going to review yourself, all right, what it says is, okay, yeah, a centimeter is like 1/100th of a meter. I like to think about it a different way. I like to think about fitting the small things into big things. If you look at what this prefactor means, centimeters are small, and in fact, there are 100 centimeters in a meter. So this is a definition, this is an equality. Now, how does that fit into conversion factors again, right? It's a conversion factor because when we know we have an equality, we can build a fraction. 1 meter over 100 centimeters can be used to take meters and centimeters information and interrelate them. We could also flip it and write 100 centimeters over 1 meter. Any equality that you see, even those with prefixes, can be used as a conversion factor. One last example. A kilometer is really big relative to a meter. We know that kili has something to do with 1,000. Oh, that must mean there's 1,000 meters inside 1 kilometer. You should be able to go through this slide 3 on the PowerPoint, and look at these equalities and build conversion factors because we'll need them in problems. But again, just to drive home this general idea, any equality is a conversion factor. Any fraction is a conversion factor. And all we have to do is get really good at sticking these guys together in the correct order, in the correct way, staying organized to take one bit of information and translate it into a more useful bit of information. So let's actually try to do this with a couple examples involving lead actually. Okay, so remember that density that we wrote down? Let's use it in 2 different problems here. Okay, so example, a 15.0 pound block of lead occupies how many inches cubed? Okay, so we have everything now at our disposal to attack this problem and get at converting a bit of information that we're given, something that we're asked to analyze, into a different and useful context. Essentially what we're given here is we're given a mass and we're told to turn that mass into a volume. So based off the discussion that we've just had, we know what relates mass and volume. We know that density relates mass and volume. Now, based on our conversion factor skills though, how are we supposed to set this up? Well, are we given something to analyze? Absolutely. That goes on the left-hand side of our paper. I'm not just going to write this as 15.0 pounds though. I'm going to get really used to including chemical identity along the way as well. 15.0 pounds of lead will go on the left-hand side of my paper. What's the goal? This is what we're told to analyze. We're told to analyze it and figure out how many inches cubed of lead there are. How many inches cubed of lead there are. I write the goal on the right-hand side. And now I think about how I can link these two together based off of information that I know, okay? So the way that you sort of know that you have to work towards density, one more time, is that you're asked to relate mass and volume. But what you know about lead is that there are 11.34 grams of lead per milliliter of lead. I can't really use this conversion factor directly because I don't see grams and I don't see milliliters either in my setup or in my goal. But I do know that this is a mass, and I do know that this is a mass. And I do have that conversion factor slide to look at in terms of information, okay? I can look at that slide show, and I'm just gonna do this the way like Chem 101 would do it. They use a slightly different value, and I'm just gonna introduce it here. And what we can find is that there is 1 pound for every 0.454 kilograms of a substance, okay? Now, I'm not just going to include pounds and kilograms here. I'm going to put lead here as an identifier as well. Okay. Now, why in the world would I use this as a conversion factor? Well, if I look at that chart, if I can take pounds and make it kilograms, do I know how kilograms and grams relate to each other? Well, yeah, grams and kilograms, they just differ by a prefix. And I know how to deal with prefixes. Okay. You'll find on the slideshow, I think your slideshow uses 0.4536 kilograms of lead on the top here. Okay. Don't worry about that. Like I said, I wanted to use Chem 101. Chem 101 uses 0.454 kilograms of lead per 1 pound of lead as a conversion factor. But the general idea still remains. We relate pounds to kilograms because now, next to this, and even though I have this as my goal, I'm just going to erase it because we're going to run out of room here. We're going to remember where we're going though. All right, I can say, kilograms are bigger than grams. 1 kilogram of lead must contain 1,000 grams of lead. Now notice that wasn't given in the problem. That's something that we just have to know how to enact, know how to do based off of memorizing the prefix slide and being comfortable with using those definitions therein. Now do I see grams of lead here? Yeah. And do I have a density that has grams of lead in it? Sure. And remember, this is a conversion factor. The 11.34 is stuck to the grams of lead. So my next step is going to be to write 11.34 grams of lead in the bottom is every 1 milliliter of lead. 11.34 grams of lead are in every 1 milliliter of lead. Okay, so I use this density as a conversion factor. And are we allowed to flip conversion factors and it's still multiplication by 1? Absolutely. So now I have milliliters of lead, but remember what the goal is. The goal is inches cubed of lead. So a milliliter, inches cubed. Oh, so now I have to remember some things that I asked you to memorize, okay? And one was on the last little thing that we did in this video, another conversion factor that we talked about, all right? 1 milliliter of lead, and remember, this would be written here. I just ran out of room, so if you have space in your paper, write it here. But I'm just going to write it down here. It's still multiplying whatever we have there, right? 1 milliliter of lead is the same as 1 centimeter cubed of lead, and that's the definition. Now, why this helps me is because do I know how centimeters cubed and inches cubed relate to each other? No, but I do know how a centimeter relates to an inch. So this was something that we had memorized from our previous video. 2.54 centimeters is 1 inch. But if I look here at what happened, okay, I can use this, but this only gets rid of 1 of these centimeters. So how many times would I actually have to use this to get rid of 3 of these centimeters? I would actually have to use it 3 times. Now you can imagine me writing this conversion factor 2 more times, and then all the centimeters would go away. We would have 3 inches on the top. Oh, and we would reach our goal. Now we avoid writing it 3 times because we kind of know mathematically there's a simpler way to write that. How many times do I have to use this conversion factor? I have to use it 3 times. So I'm going to put this up here as a superscript. I'm going to cube this whole conversion factor, use it 3 times because I don't have to get rid of 1 centimeters. I have to get rid of 1, 2, 3 centimeters. I don't want just inches out of my answer. What do I want? I want 1, 2, 3 inches all multiplying each other. I want an inches cubed. Okay. How many times do we divide by 2.54? 3 times. All right. This means we use this conversion factor 3 times, okay? 2.54 centimeters cubed is not 1 inch cubed. 2.54 cubed centimeters cubed is 1 inch cubed. Everything on the inside here gets cubed. Now we have everything set up using density, using prefixes, using conversion factors, and raising them to powers. It's a real comprehensive example where we see pounds goes away, kilograms goes away, grams goes away, milliliters goes away, 1, 2, 3 centimeters, 1, 2, 3 centimeters, centimeters cubed is going to go away as centimeters cubed, inches, 1, 2, inches cubed is the result. I plug this into my calculator. I see, oh, I'm doing math. So I check significant figures. This is all multiplication, 3 significant figures here, 3 significant figures here. This is a definition, so it doesn't affect significant figures. This 1 in the denominator doesn't matter either. Always look at the decimal thing, the decimal part of a conversion factor. That's giving you what the measurement is. 3 significant figures, 3 significant figures, exact number because it's a definition. 4 significant figures, exact definition, exact definition. I go through that, multiplication, the number of significant figures matter. Oh, my answer should have 3 significant figures. And I'm just going to write it in scientific notation. And please confirm this by yourself. And if something doesn't match in terms of my answer and yours, make sure you send me an email and we can talk about it. It could be that I made a mistake, so please check my work. But now what we've done is with this conversion factor process, we've taken 15 pounds of lead, and actually 15 pounds of lead, it turns out, is 9.84 times 10 to the third inches cubed of lead, right? So please take us some time to rewatch this part, to take a step back, to understand the ideas, because once you have these ideas mastered, there's no conversion factor problem that it could really throw at you that's more difficult. You stay organized, you start with what you're told to analyze, you work towards what you're trying to get to, what your goal is, you remember definitions along the way, okay? You keep track of identity. Even in the simple case where it's all lead, like I said, just getting used to keeping track of identity is going to be important, right? So I'm going to set up another problem, and then I actually want you to kind of try it yourself, like pause the video and give it a shot. And it has to do with lead again, so you can use the density of lead again. And then we're going to go over it one more time together. So it's like one last example we're going to do. All right. So now, how many kilograms of lead, right, are in a block of lead with a volume of 1.6259 times 10 to the minus 8 kilometers cubed. Okay, so like I said, all right, maybe pause this, think about how you would set it up, see where you get stuck, and then we're going to go through this step by step. So let's analyze this problem like we do everyone. What are we told to analyze? We're told to analyze this block that's 1.6259 times 10 to the minus 8th kilometers cubed of lead. Where are we trying to get to? We're trying to get to kilograms of lead. Now I'm going to write it down here because we're going to need some more room. But I write my goal on the right-hand side. Okay? So I have kilometers cubed of lead. I'm trying to get to kilograms of lead. Kilograms of lead. Kilometers cubed, cubic meters, cubic kilometers, that's a volume. How to relate volume to a mass, all right, with density. So again, though, I think about the units inside my density, and what I have to do is I have to think about, in my density, which was 11.34 grams of lead per milliliter of lead, I didn't have kilometers cubed. I didn't have meters cubed or centimeters cubed. I had milliliters. Oh, if I have milliliters, I really do have centimeters cubed. Okay, so I'm going to focus there. I'm going to focus on taking this and making it milliliters. Because once I make this milliliters, I then can use this conversion factor. And if I can get and use this conversion factor and get grams, do I know of the relationship between grams and kilograms? Well, yeah, I'm a great student, and I've memorized that. Okay, so here's how we start. I'm going to use a different color. Thing we're asked to analyze. Here's our goal. Okay, I know that if I work towards centimeters cubed, a centimeters cubed is a milliliter. So I'm going to do this in a multi-step process. Maybe you can think about a quicker way to do it, but I'm going to show you just how I think about it, all right? 1 kilometer of lead, okay, is 1,000 meters of lead. Now I would have to use this 3 times because I have a kilometer cubed here. So when I do my math, I'm going to multiply by 1,000 3 times. But the reason that this is an important start is I've now taken kilometers cubed and I've made it meters cubed. This will be very helpful because I know that for every 1 meter of lead, that's 100 centimeters of lead. And in fact, I have a meters cubed here. If I cube that conversion factor and I multiply by 100 3 times, then I'm left with a centimeters cubed of lead. And that's really important because I've memorized that 1 centimeter cubed of lead is defined as 1 milliliter of lead. Okay? So hopefully you can see the thought process. I'm trying to kind of walk you through what goes through in my mind, and you want to get there where you have that same narrative discussion with yourself where you're kind of thinking about, okay, what do I have to get to? What are my goals? What am I going to use in the middle to relate the different properties that I'm looking at? I'm now at milliliters of lead. So now I can jump to trying to make my mass correct because, right, I know that 11.34 grams of lead is the same as 1 milliliter of lead. And my goal is kilograms of lead, and so I know that 1,000 grams of lead is 1 kilogram of lead. And with that simple thought process, right, just kind of doing the same steps over and over again, the same checks, the same narrative in your head, we can now plug this into our calculator. And what we get out is this number, 1.84377706 times 10 to the 5th kilograms of lead. And you might report this, you might put this into Chem 101, and it's going to flag it as wrong because what have we not checked? Significant figures. Okay, so every time we do math, we realize we need to utilize significant figures. This must have come from a measurement. I'm just doing multiplication here. So if it comes from a measurement and I'm doing multiplication, okay, significant figures matter. The number of significant figures matter. So this has 1, 2, 3, 4, 5 significant figures. Definition doesn't affect our calculation. It's exact. Exact doesn't affect our calculation. Exact doesn't affect our calculation. Are densities measured or are they definitions? You would have to put a known volume of lead on a balance to figure out how much mass it has to make this ratio. Density is like a property of the substance. It's definitely something we have to measure. It's not something that's defined. So this is 1, 2, 3, 4 significant figures. All right. This is a definition. So in terms of significant figures, this has the lowest number of significant figures. So my answer should have that same amount of significant figures. So what you report to the correct number of significant figures, all right, and what you input into Chem 101 is 1.844 times 10 to the 5th kilograms of lead. Okay. So we took some extra time with this video to just kind of introduce some concepts, but also reinforce concepts associated with conversion factors. It takes practice, but it's worth the upfront effort. It's worth kind of busting your butt now to make sure you get it, because we do this sort of process again and again and again throughout the semester when we bring it into the context of chemical reactions. Okay? So try to digest this, watch it as much as you need. Contact me with questions, okay? And then see how the homework goes. Try the book problems first, then get into Chem 101. And as always, take pictures of your work. Anything that comes up, just come and get help with electronically. Let me know what's going on and I'll give you a hand.